Good morning, everybody. Welcome to a new edition of Test Prep Time. It's 11 a.m. Eastern, and that means it's time for prep. I'm going to do what I always do, which is just give another 20 seconds or so to get on the video and to log on before we get started. And in the meantime, I can just introduce myself. Andrew Peterson, Director of Education at Method Test Prep. I'm happy as always to be spending some time with all of you here on Friday morning with a little bit of a test prep tip. Today we're going to be talking about SAT math timing efficiency. Even though this is geared specifically toward the SAT, it is helpful in general to deal with not only SAT math, but all of the SAT sections so far as timing management and difficulty management. And it can also be applicable to the ACT. It's just the examples we're going to be using today are more specifically geared toward the SAT ones. So I'm going to give it just a little bit of time here, and then we'll get started. Looking forward to getting going with everyone. Okay, so let's get down into it. And first, as always, just a reminder to all of you, we do offer online tutoring not only for SAT and ACT tests, but for all subjects. We do get a lot of requests for all types of tutoring, and we want to make sure that everyone that's on this presentation right now or is listening to any of our videos takes advantage of this service if it's something that you need. You can always give us a call. Number will be at the end of the video as always, or visit us at methodtestprep.com/online-tutoring. Okay. So today's presentation, as I mentioned in the beginning of the video, is going to be on timing, specifically for the math section, specifically for SAT, but this is very helpful in general for students who are looking to try to manage their time frames better on these timed exams. We know that both the SAT and ACT are timed, and therefore this added challenge is present on the test. Not only do we need to know what we're doing and how to do it, but we need to do it expeditiously in a timely fashion. And here's some general tips about the math sections on the SAT. And we're going to take a bit of a deeper dive into this in the next slide, but at least to get started for those who aren't familiar, the SAT has two math sections, the first of which, section 3, does not permit the use of a calculator. It's a 20-question section, and students are allotted 25 minutes with regular time to finish that section. The section is comprised of 15 multiple choice questions, and those questions range from easy to hard, and this little arrow that I put in here is indicative of the fact that as you go through these questions, so as you go from 1 to 15, the difficulty generally increases question to question. Now, obviously, this can vary not only test to test, but student to student. Sometimes students that feel a little stronger in, say, algebra as opposed to geometry, they may find a quote-unquote tougher algebra question easier than a quote-unquote easy geometry question. So again, this is student to student, but generally speaking, difficulty increases as we go from question 1 to question 15. But also, in addition to these multiple choice questions, we have these things called grid-ins on the SAT. And the grid-in questions do not have multiple choice answers. Students are required to freely respond to these questions and then grid in their answer to a special answer key on their Scantron. Now, while these questions are different and they pose their own challenges, that's not really something we'll be getting into today. But what we will be getting into is the fact that these grid-ins basically reset the difficulty. And here's a nice little tip for everyone. You almost want to think about each of your math sections on the SAT as 2 sections each. So here on section 3, the no calculator, you want to think about one section, questions 1 through 15 for multiple choice, and a second section that comes immediately thereafter. That's a 5-question section for grid-in questions. And the reason we want to do this is that this easy to hard pattern that occurs, it occurs twice over the course of this single no calculator section. And that's really important because immediately after this really hard question at the end, question 15, we jump right into this very easy question that we get for a grid-in. And it's important to understand this both for timing and for efficiency and maximizing score. And that's because every single question, regardless of difficulty, is worth exactly the same number of points. So what's our priority here? Well, other than getting a 1600, or if we're in the case of the ACT, a 36, our priority is scoring as many points as possible, as quickly as possible. And so the priority there would be the easiest questions. If they're going to give us the same amount of credit, despite the fact that they are easier, that's a better bet for us as students, because that's going to be the best way to increase your score on the test as quickly and efficiently as possible. To cover the section 4 calculator section over here really quickly, in the same vein that we just discussed on the no calculator portion, this section has 38 questions. 55 minutes are allotted for students to finish the section. And again, this is sort of broken down into what I like to call 2 different sections. 30 multiple choice questions and 8 grid-ins with the same pattern emerging, right? Easy to hard, great, questions 1 through 30. Easy to hard, questions 31 through 38. All right, let's take a bit of a deeper dive and see what this means time-wise. So what I did here is I broke down each of these question sets. So here on no calculator, we have the first 15 multiple choice, followed by these 5 grid-ins. Same thing over here on the right-hand side. For your calculator sets, we have the first 30 multiple choice, followed by 31 through 38, the 8 grid-ins at the end of that section. And the biggest focus that I want to focus on here really is this: what kind of bridges the gap in that space here that I left between these different sets. And this is what we're talking about when we mention that we get this long set, say 5 or so questions that are fairly challenging, and that's immediately followed by a couple of easy questions. So remember, if we're short on time, and generally speaking, this is a broad brushstroke, it does not apply to everyone, but generally speaking, students have a little bit more of a timing issue with the no calculator section than the calculator section. Remember, this is a 20 question section in 25 minutes. That's not a very big difference between the number of questions and the number of minutes. Whereas over here on section 4, it's a 38 question section in 55 minutes, a bit of a bigger gap. So you have some more time per question on the calculator set. So it's very important here that when we're spending our time, we're doing so appropriately. And even if you're getting kind of bogged down, it's not that questions 11 through 15 aren't important, but questions 16 and 17 score-wise are just as important, and they are easier. So if you find yourself really struggling for time on the math section, and you really get bogged down in these questions 11 through 15, trying to really work the best way you can through questions that are certainly tougher, require more steps and more time, and then you find that you're running out of time in your grid-in section and you're kind of rushing some of these questions, that may not be the best strategy. It may be better for you not to skip questions 11 through 15 entirely, but forgo them temporarily. Take a look at some of these easier, possibly even medium difficulty grid-in questions, and then go back and deal with these tougher ones at the end. This will allow you to budget your time better and hopefully get a higher score on the test. The same thing is true over on the right-hand side for section 4. It's just a bit of a longer section, but we're focused right here. These last 10 questions that we get are genuinely pretty challenging, and then these first 3 or so that we get over here on the grid-in are relatively easier. So make sure you're taking a look at these numbers, these questions, and adjusting your strategy accordingly to make sure that you're maximizing your score. Now, of course, since this is a test prep time session, we're going to get into a couple of questions, and this is not just a presentation about structure. This is a presentation about questions that we're actually going to get. So we are going to get into a couple of questions that can help save time. And what I did here is I selected a question 15 and 16 from a no calculator set so that we can visually get a very good sense of what I'm talking about here when I say that question 15 is pretty tough and question 16 is a little bit more straightforward. And I selected these 2 questions specifically because even for non-students, it should be pretty apparent here that question 15 just visually looks much more challenging than question 16 does. And I'll also back it up that the math in 15 is a little bit more involved than the math in 16, unsurprisingly. So make sure that we're aware here that even though we're moving in the direction where we would think questions are getting tougher, and maybe we're a little reticent to get into the grid-in section because it doesn't have multiple choice answers, and that can be a bit of a challenge. Hopefully with this back-to-back slide right here, 15 and 16, the questions juxtaposed on this slide, we're going to get a good sense of why it may be a really good idea to prioritize question 16 over 15. Remember, they're worth exactly the same number of points. And what we're going to do right now is we're going to take a bit of a deeper dive into questions like 16. Not because they're easy or easier than 15, but because a question like 16 that obviously is a better bet at scoring points than a question like 15, there's even an easier way to solve than most students think. So let's take a look at that. What are we looking for in questions like these? So we can actually find time-saving tactics inside of questions as well. It's not just about structure and making sure that we're planning each section appropriately. It's about dealing with the challenge that is present in the question as you see it and making the best use of all the math tools that you have at your disposal to answer each individual question. So what we're looking for questions where we can save a little bit of time, we're looking for questions that are not solving for X, but they're rather solving for something more complex. And I put the complex in quotation marks here because my comment and what I'm trying to mention is that rather than looking for X, we're looking for X plus 4. Now, technically, this is more complex than X because it's not just an X, it has a plus 4, but I don't mean to say that by complex we mean something that we've never seen before or makes us feel uncomfortable. I just mean we're not doing what we typically do in math class. Students that are listening right now, how many times do you think, you probably can't even count, how many times do you think you have solved for X or some other variable in math class? Again, you probably won't be able to count this number. It's been a lot of times. And doing this job as frequently as I have, I've definitely done it more times than I can count myself. So that said, when we get something like X plus 4, this shouldn't necessarily make us uncomfortable, but it should kind of ring a bell that, this is interesting. They're not just looking for the value of X, but they're looking for the value of X plus 4. Other things that we're looking for as we sort of dive into this question right here. Simple arithmetic relationships between what we're given and what we're solving for. So like I said, be aware that in this case, we're solving for X plus 4, not just X. Now, most students who would do this problem, again, really wouldn't be too concerned about it. They would write the question out and they would proceed to solve for X. Of course they would. This is what they've been trained to do for years on end in math class. They would subtract an 8 from both sides. They would be left with 2x equals 8. They would divide by 2 on both sides. And again, we would find here that x is equal to 4. Hey, good for us. That's awesome. So if x is equal to 4, we just solve for our variable, classic math approach. We can plug this in for x over here and solve the question. We would get 4 plus 4. And of course, our answer in this case would be 8. Hey, not too bad. No sweat off our back, really wasn't that tough of a solution moving forward. But like I said, there's an easier way to do this. So if we notice, as I'm erasing some of these things here, if we notice that we're solving for x plus 4, not just x, and you see something like this in your question, take a look at what you've been given, and then take a look at what you're actually solving for, and see if there's a relationship between these two things. What I notice here is that what we've been given, 2x plus 8, it definitely has a relationship to x plus 4. That relationship specifically is that it is 2 times the value of x plus 4, right? If I multiply x plus 4 by 2, I would double the x to get 2x. I double the 4 to get 8. So all I really need to do here, instead of solving for x and then plugging back in, is just take what I've been given, knowing what I'm looking for, x plus 4, and find immediately what I'm looking for, just by dividing by 2. That means that I will get x plus 4 over on the left-hand side, and I will get 8, the answer that we established previously in the solution of this question, for the answer. This is faster, it's going to help you save time, and that's what we're all about on the SAT. Let's take a look at some extra examples. Okay, so here we go. 4x plus 2 equals 4. What are we looking for again? Oh yeah, we're looking for some type of quote-unquote complex solution. Oh, 2x plus 1, it's not just a regular x. Okay, well maybe there's a relationship between this and the one given above. And of course there is. This is the same relationship that we just saw, right? 4x plus 2 equals 4. Well, if we're looking for 2x plus 1, which is half the value of 4x plus 2, we can just divide by 2 on both sides, and we're going to be right at our solution. 4x divided by 2 is 2x, 2 divided by 2 is 1, and then 4 divided by 2 on the other side is 2. And we're done, and we don't need to solve for x, and we don't need to go back and plug in. Even though in this case it's not saving a ton of time, this adds up. If you could do this for every question and you save 10 seconds on every question, you would be saving a lot of time, several minutes over the course of a section, just finding and exploiting tricks like this. Let's check out another one. All right, a little bit more complicated here, but let's take a look at what we're solving for. 5x plus 5y, not x, not y, 5x plus 5y. Okay, well, let's take a look at what we're given, and let's see if we can solve this quickly. Now, if we weren't aware of this trick that we're talking about, a lot of students would try to match their coefficients. Maybe multiply the top equation by 3, the bottom equation by 2. This would give us 6x in both equations. And then we could subtract both equations from each other. This is a pretty inline and standard solution for a system. But I've got better news for you. We're not going to do all this work and spend all this time, because if we're trying to find 5x and 5y, notice that we can just add these two things together immediately. 2x and 3x gives us 5x, 3y and 2y give us 5y, and then 1200 and 1300 added together give us 2500. This is the solution to the question, and it's the same solution you would get if you solved for x and y independently, multiplied both of those by 5, and added them together. We can just do this faster, and good for us. Let's take a look at another example. Okay, so we're solving for 3x plus 3y here. Again, not x, not y, something more complex. Okay, well, let's take a look. This is similar to the one that we just did. We've been given a system here. But rather than adding, notice if we add, we'd get 7 plus 4, we'd get 11x. And then we would get negative 13y. Well, we're not looking for 11x minus 13y. We're looking for 3x plus 3y. Okay, so maybe it's not addition. Maybe it's subtraction. Okay, well, let's check this out. If we do 7x minus 4x, we're left with 3x. Good start. And if we do negative 5y minus negative 8y, notice that that double negative, that turns this into a positive. And negative 5 plus 8 is positive 3y. Excellent. Okay. And all we did there was subtract, right? So 4 minus 9 is negative 5. And we can happily and correctly circle answer choice B in this case. All right, we've got one more. We're making great time. It's a beautiful thing about this session. It's about timeliness, and we're moving very quickly. And this one looks a little bit more challenging, and that's why I put it last. It doesn't really look immediately like there's a relationship. The couple that we talked about system-wise, right, when we're given two equations, were ones where we could immediately add and immediately subtract them. But notice if we try this here, let me try to stack them. 4w plus 5t, right, equals 25. And 2w plus 4t equals 14. All right, if I tried to subtract these here, it wouldn't really work, right? 4w minus 2w, we'd get 2w, which looks like it's a good start, but then when we do 5t minus 4t, right, we only get 1t, and that's not good enough. We're looking for 3t, so that's a little bit frustrating. We can't necessarily do it that way. And we also notice that when we add these, as I'm moving backwards here, when we add these, we also don't get 2w plus 3t. We get 6w plus 9t, and that's going to be equal in this case to 39. But this step actually was not a waste of time. Looks like it might be, and it looks like we might be stuck. We might have to solve for W and T independently, multiply W by 2, T by 3, and then add them together. But check this out. We just put ourselves in a position where what we now have after addition, this has a relationship to this, much in the same way that there was that relationship that existed between those first couple of problems that I gave you. 2W plus 3T is actually 1/3 of 6W plus 9T, right? If I divide this by 3, 6W divided by 3 is 2W, 9T divided by 3 is 3T, and yes, 39 divided by 3 is 13, and rather than doing all that work, we can settle happily on answer choice C. Very nicely done. All right. Great job today, everyone. Just as a couple reminders, we have a test prep time plus coming up at 1 p.m. Eastern. We've gotten a lot of good feedback about our classes here, so if you haven't checked it out yet, please make sure to do so. You can sign up at methodtestprep.com/test-prep-time-plus or call 877-871-PREP. We also have an online self-paced program. It's amazing and excellent. And if you haven't checked this one out, you also should do it. Please use code FUTURE to get 50% off the offer. It's normally $199, but we're offering it up for $99.50 plus tax. So take advantage of that as well. We are also offering SAT and ACT classes for all situations. There are multiple times and days to fit your schedule. We know schedules are crazy right now, but at least take a look to see if these classes fit your schedules. www.methodtestprep.com/classes. And lastly, if you have any questions or anything you want to discuss with us, whether you're looking to get going or just ask questions about the process, we are always here to help. Please feel free to give us a ring, 877-871-PREP. You can find us at methodtestprep.com and check out our blog, info.methodtestprep.com/blog. Thanks again, everyone, for joining, and we will see you next Monday at 11 a.m. Eastern for the next session.